beautiful people. Today we are diving into the bias variance trade off, a concept that might sound a bit technical, but don't worry, it will make sense soon. So imagine you are trying to hit a target with a bow and arrow. If your arrows consistently land far from the target, that's like having high bias. Your aim is off. You're not aiming well. But if your arrows land all over the place, sometimes close to the target, sometimes far from the target, that's like having a high variance. Your aim is inconsistent. But if we get the good of both, that is, correct and consistent aim, then our work is done, right? So, in the world of machine learning, bias refers to error due to overly simplistic models, meaning the model is too simple to learn from our dataset. These models assume too much and don't capture the underlying patterns well. On the other hand, variance refers to errors due to overly complex models that capture noise rather than actual pattern. So let's take the example of predicting house prices. Imagine you are using a dataset with one feature, say the size of the house, to predict its price. For now, let's only consider the training data and remove our testing data from here. If you are using a simple linear model, it might draw a straight line through the data points, giving you a general trend but missing out on most of the nuanced patterns. This is where high bias comes in. Your model is too simple and overlooks important details, leading to underfitting. So here the model is not performing well on training data because of high bias. On the other hand, if you use a more complex model like a high degree polynomial, it might try to draw a curve that fits every single data point perfectly. You might ask, if it fits perfectly, what's the issue here? Well, this might look impressive on the training data. The model could be capturing noise or random fluctuations that don't represent the underlying trend. So, if we get back our testing data here and take away the training data, the predictions will look like this. This is high variance. Your model is too complex. It is fitting the training data too closely and struggling to generalize to new, unseen data, leading to overfitting. So, for testing data, it might look like this, where the predictions are really off the mark. So, the sweet spot is finding a balance between these two extremes. You want a model that's complex enough to capture the important trends, but not so complex that it overreacts to every little fluctuation in the training data. This balanced model is where you minimize both bias and variance, giving you the best performance on unseen data. To have a good balance between bias and variance, we can use cross validation, ensemble methods like backing and boosting, and regularization techniques. Using a larger training dataset might also be a good option. You can check my videos on cross validation and bagging and boosting to understand these techniques better. I will be covering regularization techniques very soon. So, this is the end of the video, and I will see you in the next one. Bye bye.